All right, today we are looking at section 1.2a. We're going to end up spending 5 total days on section 1.2, which, as you might guess, means we're going to do a lot of review. So we're beginning this section with some review, and this is on the order of operations. So hopefully you have some pre-built experience with this. If not, well, we're going to be building that during this lesson. So the order of operations, we have this fun little thing that we use to remember our order of operations, and it is PEMDAS. So we got 6 parts to it, and we need to remember what we're doing with those parts. And each one of these letters stands for something. So P stands for our parentheses. So this includes symbols like this, not necessarily with a comma, I should not have put that there, and also sometimes square brackets as well. E, well, those are our exponents. You may not have much familiarity with those. We'll be spending a lot more time with exponents in the future, rest assured. M is our multiplication, or multiply. D is division, and you can probably already guess that A will be our addition, and S our subtraction. So, this is unfortunately not all we need to know about PEMDAS, because you're not actually just supposed to do them in the order presented here. We also need to worry about multiplication and division and addition and subtraction in particular. And the reason for that is because each of them are done left to right. So you don't actually go in the order multiplication and then division. You do multiplication and division in whatever order they appear in the problem. So that's something you've got to keep an eye out for. In addition to that, there's also one very special example with parentheses. Parentheses are occasionally implied. If we were to look at the fraction, for example, 10 plus 3 divided by 2, it should be pretty obvious to you that we should add 10 and 3 together before doing our division by 2. So in this case, we have what are called implied parentheses. Most of the time that this comes up is just when we have fractions like this, so it's usually not too much concern, although this is one specific example you need to watch out for with our parentheses. So with PEMDAS in mind, now that we know what order we need to do some stuff, let's go ahead and take a look at some examples. So our first example, example 1, is parenthesis 10 plus 5, close parenthesis, divided by 15. If the parentheses were not there, we would do our division first. But since we have a set of parentheses, we need to do the parentheses first. So we first have to do 10 plus 5, which I hope you're able to immediately recognize is just 15. And 15 divided by 15 then equals 1. Obviously, if we did the division first and did 5 divided by 15, the answer would end up being very different. This particular example right here can also actually be written with implied parentheses. For example, if we did 10 plus 5 in our numerator and 15 in our denominator, the numerator being the top of the fraction and the denominator being the bottom, in which case the problem would still proceed in the same way. It would still be 15 divided by 15, and it would still equal 1, but we would not have the benefit of having the parentheses there explicitly telling us to do 10 plus 5 first. We would have to infer it from the context. All right, so that one was relatively straightforward until I managed to make it way more complicated at the end. But let's move on to another example, example 2. On this one, what we have is 7 times 9 minus 8 times 6. So you might need to crack out the old multiplication table if you're not sure what these end up being. But if we go back to our order of operations at the top, parentheses, exponents, multiplication, and division, and then addition and subtraction, you clearly see that addition and subtraction comes after multiplication. So we need to multiply first. So we got to figure out what 7 times 9 is and what 8 times 6 is. Now, if you want to make an attempt on this on your own, pause the video. But 7 times 9 is 63. We still have our minus sign. 8 times 6 is 48. So our question asks us, what is 63 minus 48? And through a little bit of processing, I'm sure you can figure out it is simply 15. Moving on to our third example. And as always, you should be pausing the video if I'm going too fast. That's one of the nice things about the videos. I get to go fast, and you can pause me whenever you want. If we look at example 3, this is where things are going to get a little bit wild, and we're going to have to pull in some information about exponents, which you may not have too much familiarity with, but I think it's still fun to throw something like this at you, especially since it's just notes. This one is 3 plus parenthesis 2 squared minus 7 parenthesis close square plus parenthesis 5 minus 9. Now, I can understand why you might initially be overwhelmed by this, but we just got to go one step at a time. And our first step is evaluating our parentheses. So we need to evaluate what is going on inside our parentheses. So we're going to start with this stuff right here, and also this stuff right here in separate lines. So in our first parenthesis, we have 2 squared minus 7. So we need to figure out what 2 squared is to begin with. 2 squared, that exponent, what it tells us is we need to multiply this 2 by itself 2 times. So we need to do 2 times 2 essentially. 2 times 2, however, is just 4. So inside this parenthesis, we have 4 minus 7 to the second power. And then we still have plus, 5 minus 9. What is 5 minus 9? Well, 9 minus 5 is 4. But since 9 is the negative number and it's bigger, our answer will be a negative 4. And then in front here, we still just have a plus 3. Now, we're still not done fooling around inside of our parentheses here, as we got to figure out what 4 minus 7 is. And you can take a moment and decide what 4 minus 7 is, but you'll pretty quickly find out that 4 minus 7 is negative 3. So in our parentheses, we have a negative 3 squared, and over here, we have plus negative 4, which is the same as just subtract 4. Or if you prefer to keep it as an addition of a negative number, that's fine too. Now, this is where this problem gets potentially tricky, because you might be tempted to say, oh, 3 plus negative 3 is 0. That's great. But remember our order of operations. Plus addition up here comes all the way at the end. We need to evaluate our parentheses and exponents first. In particular, we have an exponent to look at right now. I used the same reasoning when I did 2 squared instead of 2 minus 7 here. I had to do an exponent before I could do a subtraction. So, what is negative 3 squared? Again, negative 3 squared is negative 3 multiplied by itself 2 times. So it's negative 3 times negative 3. And that ends up giving us a 9. So we have 3 plus still sitting on the outside. We have a 9, and then we have minus 4. And finally, what we need to do from here is just evaluate left to right. Although in this problem, honestly, it doesn't really matter which one you do first. 3 plus 9 is a 12. And finally, 12 minus 4 is 8, our final answer. Well, that was a doozy. Usually there aren't quite this many things you need to do in a single problem, but boy, did we get a lot of them in this one. That's for darn sure. But that is a quick introduction on PEMDAS, although we're going to go ahead and take a look at one more problem. So if you're not done copying down, you want to pause the video here because I'm about to move to a new page.